These are the video notes for section 7.1, Simplifying Rational Expressions. In this section we will be breaking up the lesson into three parts. The first part that we're going to talk about is how to evaluate a variable expression. The first step is to substitute the given value into the variable expression. The second step is to simplify using order of operations. So if we take a look at our first example, we have to evaluate x over x minus 2 for x equals negative 3 and x equals 1. In this example, we have two given values, so we're going to end up with two answers. So in our first step, we're going to substitute negative 3 every time I see the variable x. Now we're going to simplify using order of operations, and then simplify the answer to 3/5. So we get 3/5 when you substitute x equals negative 3. Now we're going to do the second part, and we're going to substitute x equals 1. Every time I see a variable x, I'm going to substitute with 1. Simplify using order of operations, and then simplify the expression. So I get negative 1 when I plug in x equals 1 into the expression. In our next example, we're going to substitute negative 2 for the variable y and 1 for the variable x. So we're going to rewrite the expression. Then I'm going to simplify using order of operations. And then I'm going to simplify the fraction. So we get negative 1/4. This is the second part of the notes for section 7.1. In the second part, we're going to find values for the variable which makes a rational expression undefined. An undefined rational expression occurs when we divide by 0. The steps are as follows. The first one is we're going to factor the denominator if possible, set denominator equal to 0, and then solve for the variable. So in our first example, we're going to ignore the numerator. The denominator is already factored, so we're going to take the denominator, set it equal to 0, and then we're going to solve for the variable by adding 2 to both sides, so x is equal to 2. So 2 is the value that would make this expression undefined, because if we were to substitute 2 back in the denominator we would get 2 minus 2, which is 0, and when we divide by 0, that is when we have an undefined rational expression. So x equals 2 is the answer to this question. In our next example, we have the denominator as y squared minus 4, so we're going to factor the denominator, which is y plus 2 and y minus 2. Recall, this is a difference of perfect square. Then we're going to set this equal to 0. Much like we did in our last lesson, solving quadratic equations, we're going to set each of the binomials equal to 0. So I have y plus 2 equals 0, y minus 2 equals 0. Then we're going to subtract 2 on both sides here, y equals negative 2. Add 2 to both sides here, y is equal to 2. So in this example, 2 and negative 2 causes the denominator to be 0, which causes the rational expression to be undefined. Next example, we're going to factor the denominator to x plus 3, x plus 1, set it equal to 0, take each binomial, set it equal to 0, and solve. Subtract 3, we get x equals negative 3 for the first answer, and then x equals negative 1 for the second answer. This is part 3 for the notes for section 7.1, Simplifying Rational Expressions. To simplify rational expressions, the first step is to factor the numerator and denominator if possible, then simplify the expression. In our first example, we're going to factor the numerator. The GCF is 4z, so I'm left with z plus 3, and the denominator we're going to leave the same. Now we're going to simplify the expression. 4 and 4 divides out, z and z divides out, and we're left in the numerator with a z plus 3. Example, we have to factor the numerator and the denominator. The numerator factors to x minus 3, x minus 2. The denominator is x minus 3 and x plus 2. Then we're going to simplify the two binomials that are exactly the same. x minus 3 and x minus 3 divides out, and our final answer is x minus 2 over x plus 2. Example, if you notice, the two binomials look very similar, but they're slightly different because of the order of the variable and the number. In this example, what we're going to do is we're going to put the denominator in order, and we're going to write negative x plus 2. The reason why there's a negative sign in front of the x is because of the minus sign here that's in front of the x, and the reason why there's a plus sign in front of the 2 is because there's an imaginary positive sign in front of the 2 here. So now what we're going to do is we're going to follow the steps that we have, and we're going to factor. We're going to factor out a negative 1 from the denominator. Then we're going to divide out the binomials, and I'm left with 1 over negative 1, which is equal to negative 1. Next example, we're going to put the denominator in order. We're going to factor both the numerator and the denominator, x plus y, x minus y, over, factor out the negative, x minus y. Now we're going to simplify the expression by dividing out the two binomials. So I'm left with x plus y over negative 1. And to simplify this, we can pull the negative in front and then distribute the negative and get negative x minus y. In our next example, we need to factor the numerator. If you recall, when I have 4 terms in a polynomial, we're going to do factor by grouping. Because factor by grouping has several steps involved, I'm actually going to write it off to the side and write 4w squared minus 8w plus 3w minus 6. I'm going to factor by grouping here and get what it's factored to, and then write it up here so I don't have all this work up here. So I'm going to group the first two and the last two, factor out the GCF, 4w, I'm left with w minus 2. Factor out the GCF, which is 3, left with w minus 2. So the expression factors to w minus 2, 4w plus 3. So now I'm going to take the factored part and write it up here. W minus 2 times 4w plus 3 over the denominator. And I'm going to simplify the expression, divide out the two binomials. I'm left with w minus 2.